So these questions say, find a numerical value. Oh, shoot. Hold on. Okay, find a numerical value of one trig function of x. Find a numerical value of one trig function of x. So it's different. Your other problems are to prove things. This one's a little bit different. Okay, our first example. If I give you cotangent of x over cosecant, no, let's do cosine of x is equal to 2. So these instructions are different, okay? Notice that the key word here is 1. Find a numerical value of one trig function of x. Numerical value literally meaning a number. So all of your answers for these types of questions are going to be something like sine of x is equal to a number. And of course, this could just be any trig function. It doesn't matter. It's not always going to be sine, obviously, as long as it is just 1. So this is what your answers will look like for these types of questions. Okay, so notice in this first example that I gave you, it's written in 2 functions, cotangent and cosine. So I need to try to get this written in 1. Now, even though this is not a proof, it's tied together with the proof chapter, the proof section, because you're going to use the same strategies that you do to prove things to try to simplify this to get it written in the correct form. So does anybody have an idea of something that we could do, maybe a strategy that I just mentioned earlier to help break this up? Yeah, let's write everything in terms of cosine and sine. So obviously my denominator is okay. Let's rewrite my numerator. What is cotangent in terms of cosine and sine? Shoot. Cotangent is equal to cosine over sine. And then all of this is going to be over cosine. Over cosine of x equals 2. Right, tangent is sine over cosine, so cotangent is cosine over sine. And remember, guys, you will have the identities. You just need to know how to use them. So if you're looking at your reference sheet, that's one of your quotient, or that's one of your, oh yeah, it is one of the quotient identities. Okay, now here's where math comes into play. Cosine over sine divided by cosine. If I have a fraction divided by a number, instead of division, how can I rewrite this in terms of multiplication? You're close. Let's take our fraction on top, cosine over sine. Instead of dividing that by a number, dividing by the number is the same thing as doing what? Multiplying by the reciprocal. So let's multiply by, what is the reciprocal? This is already cosine over 1, so the reciprocal will be 1 over cosine x. And then now what do you notice? And if cosines cancel each other out, then that leaves us 1 over sine x is equal to 2. Now, technically, you're down to one trig function, although we really should use the reciprocal identity one more time to get it to look exactly like our answer should be, which is just a trig function with no fraction equals the number. So what is 1 over sine? Cosecant of x is equal to 2. So this is your answer. You know, this is not a proof, so you don't put the little box at the end. This is your final answer. Okay, let's do another one. Cosine squared x plus 2 sine x minus 2 equals 0. Now, the big game changer, and one of the main differences between these types of problems and proofs is that we are, and this is very informal, but we are allowed to algebra. Okay, so you are allowed to cross the equal sign in order to get this written as a trig function is equal to a numerical value. Now, my first tip of changing everything in terms of sine and cosines is not very helpful because everything is already in terms of sines and cosines. So do you have other ideas of just how maybe we can progress and try to simplify the left side? Brewski, come here. So the worst thing that you could do is say, I don't know what to do. Do you see your list of identities? Do one of those. Use one of those. So look for something that has cosine squared. Look for something that has sine. And let's try to change something. Use what you know about algebra to try to change something. Brewski, come here. Come here. Who is speaking and say it louder? Come here, Kyle. Cade, you got something? Please. Okay, we could try that. So you're suggesting if we change this cosine squared theta, if we know using the identity that sine squared theta plus cosine squared theta is equal to 1, then we could solve this just for cosine. So then we know that cosine squared theta is equal to 1 minus sine squared theta, like this. Was that what you were thinking? Okay. Okay, well that cosine squared can be written as something else. So instead of that cosine squared, let's go ahead and write 1 minus sine squared theta. And then let's copy everything else. Y'all, please know there is no right answer. Remember yesterday when I did that algebra problem and I divided everything by 3? And you were like, why? Why would you do that? I mean, you could do lots of things. So don't hesitate to say, hey, can we do this to both sides? Can we, add these, subtract these, multiply these? The worst thing you could do is not try, which is what some of you are doing right now, I think. Yeah, y'all are. Do you see something you can do? Add to, what do you mean? Sure. So that would be 1 minus sine squared theta plus 2. Oh, I changed this theta. I'm using thetas and x's. Sorry. Just pick one. Is equal to 2. Okay, cool. Now what? Everything on the left side? Okay. So basically just going back a step but changing the sign of everything? Yeah? Is that what you want to do, Sebastian? Just go back a step but change the sign? Okay. So what you could do in that case is you could either go off to the side and like take a different route, or you could just say, yeah, let me kind of back up a step and let me change the sign of everything. So if I multiply everything by -1, then I get -1 plus sine squared theta minus 2 sine theta plus 2 equals 0. All right. Okay, so like combine like terms, right? So if I combine my like terms, where did all my ink go? Okay, if we combine like terms, then we get sine squared theta minus 2 sine theta. -1 plus 2 is just +1 equals 0. Factor. What do you mean factor? What can I write? You're so close. You're so close. Do you all agree? So what Sebastian is seeing is maybe let me use the variable a instead of sine. This is a squared minus 2a plus 1 equals 0, right? But instead of signs, I just wrote a's. Y'all know how to factor this. How would you factor what two numbers multiply to be 1 and add to be -2? So right, it would be a minus 1 times a minus 1. So what that means is using the trig functions, instead of a's, I have sines, right? So I'd have sine of theta minus 1 times sine of theta minus 1 equals 0. And then, I'm trying to get it into a trig function is equal to one number. So then if I actually solve these, now both of them are the same, right? So I can literally just set one of them equal to 0. So then what is my final answer? Sine of theta is equal to 1. Fabulous.